Section 2.1, bar graphs. We're going to look at different types of bar graphs. We're going to analyze them and also graph them. So just taking a look at the try these section here, it says compare these graphs. Each graph has how many categories? So ABC, ABC, they both have 3 categories. Is it possible that both graphs show the same data? Well, they have ABC. We can take a look at B looks to be the biggest here, same in the circle graph. A is the smallest, which it is in the circle graph. If you take a look, they've kind of marked off some markings along the edges, and there's 5 sections in B, and there's 5 here in the bar graph. 3 for C, 3 for the bar graph, 2 for A. So yes, they definitely could. Next one, it says, Amy is a conservation officer. She educates people about problem bears. These are bears close to food in populated areas. What information can Amy get from this graph? So this is in a district in British Columbia. So the vertical axis is the number of bears, and then the horizontal is the year. Then you kind of have to look at the legend. We often call that the legend. The grizzly bears is the lighter of the 2 bars in each case. Black bears is the darker one. So it says describe the data in the bar graph. And so they have some places to fill in. It says the categories on the horizontal axis are, well, what are they? They're the years from, what is that, 1992 to 2001. And then the 2 groups of data are the grizzly bears and the black bears from that legend. Then it says describe the trend. As the years increased, the number of problem black bears did what until 1995? So as the problem black bears is the darker one, so darker from 1992, got bigger in 93, bigger in 94, bigger in 95. So I would say the number of black bears increased as well. Until 1995, and then they started to decrease. Maybe they had some plan in place starting in 1995, except for, so take a look, got lower, got lower, got lower, then went up again here, and then started to go back down again. So except for 1999, I'd actually probably say 1999 and then 2000 was still above 98. Okay. What is the range for each of these? So the range is the difference between the highest value and the lowest. So it gives you a little, on the left here, a little definition, the difference between the greatest and least number in a set of data. So for problem black bears, tells you the biggest is 20, okay? And then the smallest looks like for that would be either one of these, which if you look across here is 1 grid marking, which is 5. So the range is 15. For the problem grizzly bears, so the highest is definitely up here. And so we need to look at the grid markings. Each grid is 5. And so this is a little below halfway to 5, so I'd say 2. So I'd say 32 for those, and then it gives you the smallest is 1. And so that's down here. Okay, so 32 minus 1 is 31. Okay, circle the correct word. So the greater range means that the number of problem grizzly bears does it change more or less than that of black bears? So the greater range is the grizzly bears, and so that means it changed more, obviously, if it's a big difference between the two values. Okay, here's another example. Okay, and this is councils in 2 BC towns conducted a survey. They wanted to choose 3 ways to protect the bears and keep communities safe. These results are shown in the chart. What decision might they make from the data? So if you take a look here, they put these suggestions to the town to vote. So this is town 1 in this column and town 2 in this column. And so you can read through the different choices. Use safe electric fence around the landfill, remove brush in town, use bear-proof garbage cans, move problem bears to the wild, put out garbage on pickup day only, lock commercial garbage bins. So it says, what is the maximum number of votes in a category? So in all of these data, 1020 is the highest, and that's going to help us decide on our scale. Okay, so in this case, it says use the maximum number of votes to help you choose a scale for the horizontal axis. So they're actually telling us to do the number of values horizontally. So this is going to be a horizontal bar graph. And so we need to check the markings here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So really 1,000, we could go to here quite easily, right? And so that would mean, I'm just going to erase those markings. So this I'll make as 1,000, and I have to write small. Then each one of these would be 200. So each grid marking is actually 100. Every second one is 200. Okay, so that is going to be a number of votes. So we like to label those, right? And then obviously we need to put our bars on horizontally. So we need to scale them here. It says draw and label the bars for each town along the vertical axis. Shade to show the town for each bar. Use a legend to show which bars. Give the data for each town. Complete the double bar graph. Okay, so you want to look at how many categories. So 1, 2, 3, 4, 5, 6. And so let's see here. It's nice to leave a space from before the horizontal. So if we use these two here, that'd be 1, space in between 2, 3, 4, 5, 6. Good. I'm just going to erase that. I don't really need those. I just wanted to check. So they've actually got a little dash there. So that's where we can label them. Now, I'm going to kind of short form just because I don't have a lot of space. When I'm using a tablet, it's even harder. So I'm going to put electric fence. Oops, electric fence here. Okay, then remove brush. Let's see, bear-proof garbage cans. move to the wild. Pick up garbage day. Pick up day. I'll just abbreviate it. Pick up day garbage. Because some people put it out too early, right? And then even if there's not bears, there's other animals that get into it. And then lock bins. Okay. So these are the suggestions. That the towns are going to vote on. All right, so let's look at electric fence. So I'll put it always on the top one, 1020. So remember, each grid here is going to be 100. So 1020 is going to be just a little bit more than that. Okay, and so I'm just going to freehand it. You should be using a straight edge. Just takes too long on the tablet. And then I'll just fill that in with blue. I'll maybe color code it because I have color. You can just shade one and not shade the other. Remove brush in town, 294. So that's almost 300. So just a little less than 300. Okay. Use bear-proof garbage cans, 701. So just a little bit more than 700. Then move problem bears to the wild, 773. So 3/4 of the way basically to 800. Put garbage out on pickup day, 948. So basically halfway between 900 and 1,000. And 60 for locking the bins. So that's 100, so a little bit more than half. It's going to be like that. Then I'll switch to red. 711. So a little bit more than 700, so maybe about there. $47, kind of about half. 710, so just a little bit more than town 1 on that one. And then 479. $518. And 76. Okay, so it's not perfect because I didn't use a ruler, but not bad. So the red was town 2, and the blue was town 1. Okay, says mark the top 3 choices for town 1. So town 1 is blue. Mark them with a check mark. So that one, that one, that one. Mark the top 3 for town 2 with an asterisk. So that would be these there. Okay, what 2 choices would you suggest? Justify your reasons. Well, you might suggest something that's not popular here, but if I were to look at this, I'd probably go with what the vote says. So probably I'd say electric fence around electric fence around the landfill to keep them out of there. Most popular, basically. And then also probably just getting into the habit. This is also quite popular as well. Pickup day, garbage put out on pickup day. These 2 as well, bear-proof garbage cans. They're both the same actually. So maybe I would choose that one because they're both equally likely. Now it depends. They didn't tell us how many people live in each town. And they didn't give it as a percentage, so that is something to think about. But maybe bear-proof garbage cans, because that sure makes sense to me. Okay. The total votes was large. Okay. Yeah, so now you can work on the practice. Take a look. Some of the bar graphs are given to you. Data is given. You might need to get some grid paper to do some on your own. Okay, but that's your homework or your practice.